Alright, thank you for joining us today. And in the previous videos, when we started with the idea of average rate of change, and then from there we saw that average rate of change was leading us to the idea of instantaneous rate of change. And when we started instantaneous rate of change, we saw that instantaneous rate of change actually was talking about how we were using the idea of limit, like when we are using the idea of when we are getting close to one particular point, when if we have, let's say, the secant line which depends on 2 points and 1 point is getting close to what, 0, which brought the idea of instantaneous rate of change. That is the tangent line that we were talking about. So instantaneous rate of change was actually leading us to the idea of what, limit. So let's jump right in. So what is a limit? The limit of a function as s approaches a value a can be written as this, right? And this means f of x gets closer to as s is what, approaching a. So here we are looking at what is the value that f of x gets close to when we are approaching a, right? When we are approaching this one, what is f of x going to get close to? So we can use the idea of, okay, now let's get close to L, right? When we are getting close to L. Now, the important thing that we need to note from here is the value of the limit may not depend on the actual value of what, f of a, but rather on the behavior of f of x near x is equal to what, a. So here we are looking at, if we have f of a, then the limit may not depend on that, because f of a, it means that the function does not depend on what, x. We will look at the properties of limit and you understand it better. And the idea is that now we want to look at the f of x, the function f of x, which depends on x, and we want to look at what will be the behavior when we are getting close to what, a. Now let's take this example to understand the behavior or what I'm trying to say with regards to limit. So let's look at this example. Now let's assume that we have f of x which is equal to x squared. Now what is the limit as s is approaching 1? So this can be written as limit x is approaching 1 of f of x. Now we know that f of x is equal to x squared, so we are going to have limit x is approaching 1 of x squared, right? So this is what we are going to do. Now we are going to pick some values which is getting close to 1. As we learned from this here, we want to look at when we are getting near to when x is equal to a, but that one is when x is equal to what, 1. So we want to pick some values which are getting close to 1, right? Then we look at how we can examine the behavior, right? So let's assume we have x and then we have f of x, right? So let's assume that we have something like, so let's assume the first point that we are going to pick, we can pick something like 1.2. Let me pick a point like 1.1. Let me pick another point like 1.01, and let me pick a point like 1.001, right? So let me pick this 4 point, right? And let's see what is going to happen. Now we can see that the value that we are picking here, they are getting close to what, 1. These values are getting close to 1, right? Good. So now let's start looking for f of x. Now we remember from average rate of change, right, that if we want to find something, if we want to plug in something, the first thing is to make sure that we put the function in what, parentheses. So we have x squared, so this will be f of x is equal to, in bracket, squared, right? So now let's look for when s is equal to 1.2. So x is equal to 1.2 will be equal to 1.2 squared, which is going to give us 1.44 in 2 decimal place, so 1.44, right? So now let's look at when s is equal to 1.1. F of 1.1 is equal to 1.1 squared, which is going to give us 1.21, right? So we are going to have 1.21. Good. Now let's look at when s is equal to 1.01. So 1.01 squared is going to give us 1.0201, right? So 1.0201. And let's look at the last point here. So this is f of 1.001, which is going to be 1.001 squared, and this is going to give us 1.002001. 2001. So 1.002001. So let's look at the trend here. Now we can see that the more we are getting close to 1, what happens to the function f of x? F of x also gets close to 1. So now let's look at something here. Look at the table. Now you see the x value here is 1. So we were picking values that are getting close to 1. So the limit of this function will be what f of x is getting close to, right? So let's look at this one. It is 1.4, and as we are moving, you can see that this is approximately equal to what? 1, right? When we are getting close to 1, it's approximately 1. We can look at a point like 1.000001, and you will see that this one is going to give you like something like 1.0000020001, something like this. So you will see that approximately we are getting close to what? 1. So here we are going to say the limit as s is approaching 1 of x squared is equal to 1, and we are going to use the properties to solve, right? So in the context of we finding the limit, instead of picking point getting close to that value, we are going to just use the property to solve.